Hello and welcome to The Road to Net Zero, a podcast from the Advanced Propulsion Centre. My name is Clem Silverman, and the APC is well known for its role in deploying UK government grant funding for research and development and scale-up. But we at the APC are not just about funding. We're just as much about the connections and collaborations we foster to really add value. One such example is the success story of an SME from Belfast. Ionic Technologies, a 2014 spin-out company from Queens University Belfast, formerly known as Seren Technologies, has developed new techniques to recycle permanent magnets using a revolutionary process. It has received support through our Technology Developer Accelerator program and Scale-up Readiness Validation competition. Energy and transport journalist David James visited Belfast and met with Managing Director Thomas Kelly to explain where this company sits in the automotive supply chain and what the potential benefits from recycling magnets could be.
With the help of the Advanced Propulsion Centre, a company in Belfast has developed an innovative method of recycling permanent magnets to recover the individual rare earth oxides. So why is that important? Well, permanent magnets and rare earths are absolutely essential for the manufacture of a wide range of low-carbon technologies, like wind turbines and electric vehicles. No rare earths means no net zero. And right now, the UK is entirely dependent on imports of permanent magnets and rare earths because we don't have our own supply chain. We went along to Ionic Technologies in Belfast to meet their Managing Director, Thomas Kelly, to find out how they are creating a new supply of rare earth oxides recovered from end-of-life magnets. So, Thomas, tell us about Ionic Technologies.
So, Ionic Technologies is a company that is able to utilise spent magnet material, recycle it, and separate the rare earth oxides into their individual state from within that material, which is really useful because rare earths are an essential critical mineral for things like electric vehicles, wind turbines, and other high technology industries. Ionic Technologies itself spun out from Queens University in 2014, and since then it's been growing a bank of intellectual property and experimentation to better understand how the separation processes work. In April 2022, the company was purchased by the Ionic Rare Earths Group, which is an Australian company focused on rare earth and rare earth supply chain growth. And as recently as September, October of 2022, the business was still operating out of Queen's University. However, we've now moved to a custom-built facility in Harbour Estate in Belfast, which includes a demonstration plant, which has been part funded by the SuRV grant from the APC.
I know very little about rare earths other than we need them for things like wind turbines, magnets, some sort of defence and communication technologies, but what are they? Give me a little bit more background on what we're talking about here.
So the rare earth elements are a group of 17 elements within the periodic table. They're typically found out, obviously, around the world in deposits. They're notoriously difficult to extract and separate, but they're incredibly useful for lots of different applications, but particularly in terms of the EV wind sector. Permanent magnets form an essential part of these pieces of equipment, and rare earths are typically found within those magnets. So there's a real reliance on this material in terms of the net zero revolution, and so that's why they're so important. But what we found is that the supply chain in Europe, UK, US is reliant on material from China, and so there's a real drive towards developing domestic supply chains for this material so that all these things that we want, all the high technology equipment that we need, all the renewable energy equipment that we need, that this material can be sourced locally and supply chains can be developed locally as well.
So I guess it's about developing a circular economy, because we're going to have lots of wind turbines, we're going to have lots of permanent magnets in cars and other devices, and we want to get as much of that back again. Before your process, how were people recycling permanent magnets?
So the recycling of permanent magnets isn't new. It's been around for decades, in fact. However, typical processes rely on physical process in order to separate magnets into a ground material. And this can then be used to produce a magnet, which is broadly reflective of the magnet that was recycled in terms of quality and composition. However, what our technology is that's different is it involves a chemical separation. So we're able to physically extract the individual rare earths into their oxide state, which allows for the production of much more high specification permanent magnets, because we use high specification rare earths. So it is slightly different. And the other distinguishing feature, I guess, is that our process is 100% recycled material produced. So there isn't a reliance, for example, on new material, primary source material, in order to increase specification, which is quite common in recycling industries. So all the material that we produce from our process is 100% recycled. In addition, conventional technology is reliant on quite a steady, stable feedstock. Our process is agnostic and will take varying quality of end-of-life magnets, and we can extract the rare earths into their oxide state. And we can also achieve a purity which is very high. You know, most recent production run allowed us to achieve up to 99.8% purity on individual separated oxides.
Now, this is all a really big deal, isn't it? Because minerals, particularly critical minerals and rare earths, I guess, being within that, has gone from the dusty corners of academic and high-tech industry that hasn't been on people's radars, and it's now almost top of number 10 Downing Street and even the White House's agenda, European Union. It's a big deal. Just give us a sense of how big a deal this is. I know you've talked about the technology, but this is huge.
Depending on which estimates you use, it's expected that the rare earth market will double between 2021 and 2030. And what's driving that is the demand for electric vehicles, wind turbines. The latest generation of heating, ventilation and air conditioning equipment relies on rare earths for their construction. And obviously you mentioned their defence as well. So obviously this is absolutely essential, because some of the highest technology equipment that defence users have relies on rare earth material for their construction. So there's a real geopolitical sensitivity around the accessibility of this material and the demand for it, the drive for it. And it really does bring to light why our technology is so useful, because what we offer is a means to recycle existing material to produce the high specification rare earths. So the material is obviously already here. It's embedded in things like electric vehicles and wind turbines. We can then take that material and recycle it to produce the high specification rare earth oxides, which will enable us to create the next generation of EVs and wind turbines. So there's a massive, massive focus on critical minerals generally at the moment, and it's been a real focus of a lot of political activity, as you say. Well, how that translates in terms of what we're doing, we're seeing a great deal of interest from UK, EU government in terms of rare earth supply chain and the role that we can play in that. But basically, there's a real demand for this material, which is in some cases outstripping the supply already. But by 2030, we expect that the value of the sector will be something in the region of $15 billion globally.
We should come back to the business case in a little bit, but just talk about your process. Just give us as much detail as you can for a non-technical audience. Just explain how that whole process works. So you start with a permanent magnet from a motor, then what?
It can be quite hard to conceptually picture what a magnet actually looks like, because we have a vision in our heads of what we think a magnet looks like, but they come in all different shapes and sizes depending on the application. But with our process, we're relatively flexible at the front end. So we take them in and perform a physical process to break the magnet down into small parts, and we're basically able to take that, digest it, and separate out base metals. We then perform a series of extraction processes on it to individually separate the rare earth elements into their oxide state before we calcine it and prepare it for sale. So it's in itself is quite an elegant process. There's lots of different stages within that, and what it does do is it enables us to produce something that's in such high demand, something that industry is telling us it wants. And what we're looking to do then obviously is to scale that further and expand our IP and expand our knowledge base and then expand our capability as well.
So I guess a business, it's all about the business case at the end of the day. Can you do this at a price that makes it cost effective? Obviously the cost of the raw rare earths is going up, so the business case going forward looks better, but starting any new technology takes a lot of cash, a lot of time. How does that look like your business case as a company?
So we're still learning in terms of what value we represent, but what we're hearing from the supply chain is there's a real value placed around the domestic supply, the recycled nature of the material, and then of course the quality and the traceability. So obviously these things come with a cost, and there is a value behind them. So we're working with supply chain to better understand exactly what that is, but what they're telling us is there's a real demand for this recycled material, and there's a real demand for the reliable supply from within Europe, basically. So in terms of the cost of rare earths, or the cost of the magnets that we bring in, that's obviously something that we're continually monitoring. There's lots of variability in terms of quality and cost. What we're doing is expanding our capability to bring that material in and see what the cost associated with processing it is. But what we are finding is that the value of the product we produce is pretty dependable in terms of demand, and we're hearing from supply chain that they're willing to pay a premium for recycled material. However, the business case is stacking up even beyond that compared to reference prices. So from our perspective, what we're looking at developing more in our demonstration plant where we are today is better understanding our process, how we can optimize it, how we can do it better. And it is stacking up for a commercial plan, so that's the next stage of our growth.
Now, obviously, it takes a lot of money to go from a university piece of research to initial concept demonstrator to production to industry. You've been supported by the Advanced Propulsion Centre, which uses government money to support companies within the automotive sector, and I guess you're providing magnets for electric vehicles eventually. Just talk about the support you've had from the Advanced Propulsion Centre and how important it's been for your development as a company.
Yeah, so Ionic Technologies has been fortunate enough to receive £1.72 million from the Scale-up Readiness Validation competition within APC. What that's enabled us to do is to grow from where we were previously, which is at pilot scale, to where we are standing now in a demonstration scale plant. So what that means is going from relatively small volumes of product produced to where we are standing now, a plant capable of producing around 10 tonnes per annum, bringing in around 30 tonnes per annum of end-of-life magnets. So it's enabled us to scale our process up to a level where we're using pieces of equipment that a commercial plant would use as well. It's enabled us to grow our team, so we now have much more skill and capability within the business. And it's enabled us to bring in a lot of understanding, a lot of intellectual property, a lot of know-how with respect to how a plant like this needs to come together. It's also enabled us to bring in materials that we need in order to do what we do. And it's basically enabled the business to go from relatively small scale up to a point now where we have demonstration scale plant, which is attracting a lot of attention in terms of local stakeholders, UK stakeholders, European stakeholders, and beyond. The company obviously has match funded the grant, so that total amount has enabled us to progress the business, but we've done so much more than just build the plant. We've also, as I said, grown our team, and we've expanded our knowledge capability, we're expanding our IP, and we're able to do a lot more commercially as well, which has enabled us to understand our supply chain better.
So a fantastic thing that's happened to Ionic Technologies is you've got direct foreign investment from Ionic Rare Earths. Tell us about that.
So the parent company is Ionic Rare Earths. They are an Australian listed business, and they have a strategic mine located in Uganda, which the company is looking to extract from in the coming years. The company saw real opportunity in Ionic Technologies because we have great accessibility here to markets in UK and Europe, and the recycling business enables obviously the access to supply chain to be rapid. You know, we can deploy our technology very quickly, whereas obviously a mine takes a number of years to go through the various stages of development to get material into supply chain. So the company saw an opportunity in our business, not only because of our support from UK government, which was in quite an embryonic stage at that point, but also the access to skills and talent, but critically the access to supply chain as well. So they obviously are very aware of the need for rare earth material and the shortfall in supply in Europe, and saw an opportunity with our company to invest in a business that can get to those users of our product quickly and supply them quickly, and then obviously use that as an opportunity to grow the parent company in the future as the demand for that material increases as we expect it to by 2030.
Actually, just going back a little bit to the APC, they obviously provide financial support, but it's quite often much more than that, isn't it? What other benefits have there been with working with the APC?
So the APC have been fantastic in terms of obviously the funding, as you say, but also in terms of the sort of onward support. So they've introduced us to a number of colleagues in various different strands of UK government and within Innovate UK for additional support, and where there's further financial support that we can get, but also in terms of getting our voice heard as a sort of fledgling industry within rare earths in the UK. But in addition to that, during the course of the grant funding, there's a very well-structured program in terms of monitoring. But what it does for us is it prompts us to consider every quarter how we're sticking to our plan for growth. So we stipulate that at the start of the funding, at the first receipt of the funding, and then the guys from the APC will take us back to that, and we'll review it and see how things are changing and see how we're sticking to our plan, and then any changes that are happening, that why we're doing them and how it's helping. But beyond that, also they're able to provide lots of guidance, particularly with respect to supply chain and UK government support along the journey.
What are the key messages you would like to get out into the world? Who do you want to reach, and what do you want to say to them?
So what we want to make clear is that what we do here at Ionic Technologies is new, is different. So whilst magnet recycling has been around for a long time, what we do is different because our process will take any sort of permanent magnet in for recycling. We will produce a product in terms of rare earth oxide that is 100% recycled in origin. And in addition to that, because we're able to track where the materials come from that we recycle, we're able to offer a level of quality and traceability that hasn't existed before. And what we're able to do with the process that we have, which is the intelligence that we have in terms of our business, our people, our processes, we're able to produce a product then that's of very high quality, which is in demand for supply chain. So that's new for recycling. So we're in a very good position in terms of what we can do, and what we now want to do is grow our business. So we want to provide into supply chain at a level that can actually start to help with the growth of EV sector, wind sector, particularly here in the UK, but also beyond. So our next stage of growth is to look at that commercial facility, and we're looking at Belfast as a location for that. The Belfast as a location is fantastic for us because obviously we have access to lots of great people, skills and capability here is fantastic. But also Belfast Harbour has excellent infrastructure for the wind sector, the offshore wind sector. So there's a real growth industry here for the commissioning and then decommissioning of wind turbines, and coherent businesses for that activity are essential for the growth and success of it. So we're in the right place, and we're getting the right external stakeholder support, and we've got the right people. So it's a real good news story, and we're really happy with the way we're growing here.
How does it feel on a personal level to be involved in something like this?
It's an amazing project, and to be able to directly influence something that is so important to the green revolution, the net zero ambitions of the UK and the world is phenomenal. And what we do here is very special in that sense. So it's fantastic as well to sort of see the level of support a business like ours can attract. Not just the financial support, but also the government support, the sort of geopolitical benefit that we provide. We're seeing, exactly how much help we can provide or how much influence we can have. And it's been fantastic to see as well how quickly we can progress the technology. I mean, this plant's been delivered past commissioning phase. We've done that in the space of about 7 months. So it's been rapid, very quick, and to be able to contribute so much and deliver so much in such little time is a great credit to the people that work here, but also the support that we've received along the way. And yeah, it's a fantastic journey that we've been on so far, and it's really exciting to see just how we can help the UK and the world meet its net zero ambitions from what we're doing here.
Anything else you'd like to say?
Just a thank you to APC for everything that we've received so far and all the support we've received along the way. Without the support of the APC, what we've achieved here so quickly would not have been possible in the sort of time frame we've seen it. And we look forward to working with APC in future. Thank you.
So it must be, I mean, it's a very exciting time for you.
Fantastic. Yeah, really exciting for the team, really exciting for the business. And it's also really exciting for Belfast as well. As I said, we get so much local stakeholder engagement. We've had lots of different visitors to the plant already, and they're really excited to see what they can do to help us with our journey, and also to see, if we can contribute towards creating a centre for advanced manufacturing in Belfast, which is one of the key objectives of the local government here.
Thomas, thank you for your time.
Thank you very much.
Thanks for listening to this episode of The Road to Net Zero. Visit our website to read the full story on Ionic Technologies, including its latest project with Ford, Less Common Metals and British Geological Survey to potentially supply recycled material for new Ford electric vehicles.
By 2035, all new cars sold in the UK will be electric or hybrid. Most of these vehicles will have permanent magnets in their motors. By 2030, the UK has a target to deploy over 50 gigawatts of offshore wind turbines. This will require over 32 million kilos of permanent magnets. Rare earths are a vital component of permanent magnets, and right now the UK has no direct supply of them. This means UK companies wanting to produce low-carbon technologies are highly dependent on imported permanent magnets from China. However, as a rapidly increasing number of wind turbines and electric vehicles come to the end of their life, there's a growing supply of permanent magnets that need recycling. With the support of the Advanced Propulsion Centre, a company in Belfast has developed an innovative method of recycling end-of-life permanent magnets.
So Ionic Technologies has developed a technology for taking end-of-life magnets, putting them through a recycling process in order to produce 100% recycled, high-purity individual rare earth oxides. So rare earths are essential for high-technology applications such as electric vehicles and wind turbines. So this material is absolutely vital for the development of all the technologies around net zero.
Rare earths are so vital to a number of strategic technologies, they've been classified as critical minerals. Securing supplies of rare earths has become a top priority for governments around the world.
Between 80 and 90% of the world's magnets currently come from China. So there's rather a lot of sort of geopolitical challenges surrounding these materials, and certainly from a UK perspective, we don't have an indigenous supply of rare earths. We need to make sure that we have a secure supply and a resilient supply chain. If we can create our own indigenous, I suppose, urban mines to actually recycling these materials, then actually we offset the sort of the lack of a primary supply by having a secondary supply of these materials.
Rare earths aren't actually that rare. However, they are very difficult to extract and separate, so mining and refining them uses a lot of energy and acid, and also leaves a lot of waste. The Ionic Technologies method of recycling permanent magnets is a more efficient way of acquiring rare earths. But how do they do it?
So we take in magnets. First we demagnetize them. We use an oven to heat it above the Curie temperature, whereby it loses its magnetism. Then we can crush it and grind it down into a fine powder. And then we use a series of pre-treatment leaching processes to separate the rare earth metals from the non-rare earth metals. So once we've got the rare earth mixture, we use a series of mixer settlers in a solvent extraction process to separate the individual rare earths from each other.
The Advanced Propulsion Centre has helped Ionic Technologies scale their process from a Queens University research project to industrial scale readiness.
So the APC support has been fantastic. It's enabled us to scale our technology up from pilot up to demonstrator scale. So what that means is that we now have equipment in our building that is reflective of what would exist in a commercial plant.
Ionic Technologies joined the APC's Technology Developer Accelerator program as a spin-out from Queens University Belfast called Seren Technologies. On our program, they received one-to-one business support, funding to scale from lab to pilot. During that time, they were acquired by Ionic Technologies. They then won an ATF grant through our Scale-up Readiness Validation competition to build a 30-ton per year demonstration plant.
The Advanced Propulsion Centre grants and support helped unlock significant foreign direct investment.
The grant from the Advanced Propulsion Centre was perfectly timed. With that grant, we were able to effectively double down on our decision for the demonstration plant at Belfast. So it gave us the confidence to spend more money and expedite the production of separated high purity magnet rare earths from recycling in Belfast, in under 12 months.
As the world deploys more and more low carbon technology, the demand for rare earths will increase dramatically. But so too will the number of permanent magnets available for recycling. With the support of the Advanced Propulsion Centre, Ionic Technologies is poised to become a strategic component in the UK's rare earth oxide supply chain. To find out more about the work of the Advanced Propulsion Centre in supporting the UK's automotive industry transition to a low carbon future, visit apcuk.co.uk.